covering two different topics. The first group is going to be doing a project that I've kind of thrown them under the bus on. It's activity and project I've been working on, and I didn't want to do a lot of the legwork, so I made them do the legwork. As probably the brutal truth on that. For the first group, the software, they're not programmers, so I actually did the programming, so I apologize ahead of time for the quality of the software. If there are any problems, it's not their fault.
Good morning, everyone. My name is Brandon Rodriguez. I'm a junior here at the University of Memphis, engineering technology major. I'll let my partner introduce himself.
Hey y'all, my name is Caleb Pearson. I'm also a ET major here at the University of Memphis. And as you can see here today, me and Brandon created a methodology on how to create a standardization for a palette for barcode verification and scanning. So I'll go over here and show an example. Me and Brandon came over here and at first we thought of using the GS1 standardization protocol, which is 5 circular antennas, but we were 10 layers, and our goal was to be able to accurately and effectively scan an exact box for a customer to find, or for them to know whether they have lost product or not.
So yeah, like he mentioned before, we divided this into 10 layers. Each layer is composed of 120 tags. There's 20 boxes in each layer. So they're number 1 through 120. And then after that, it'll add the level that it's in. So as it goes, we'll show you in a minute in the software, but it'll tell you what level it's on as well. Like he mentioned, our setup is 5 antennas. We number it 5 all the way down to 1. We have a reader here that also has it connected. So we'll show you a little bit of how that works. We have it set up on this rotation palette right here. We're going to be doing readings of 45 degrees clockwise. So we did a few testings. We started at 90. We weren't getting that many tags because it's 1,200 tags in total. We weren't getting that many, so we decided to switch it to 45. After that, we got a better accuracy. We then decided to go a little deeper and go into 30 degrees. After we conducted that, we verified that it wasn't that much of a difference in the reading. So we decided to come back to that 45 just because we don't want it to take a long time. It's already taking 5 seconds. It's around 5 seconds per read, so it can capture all of them in each antenna, and we don't want it to be a time-consuming thing. We just want it to be verifying, popping everything that is not reading, and continuing like that. So we can go over here and we can show you the. Go back. So here we'll start off with our settings. So our settings is pretty standard. We'll have the IP address of the reader. You have to connect to one. You'll then have the antenna session. We have modes in here, but for this verification test, we won't need to mess with that. We have a tag population. For the tag population, it goes all the way up to 1,000, but it's just a sense of how many tags we could be reading in this palette. So for the session, this software in specific has 4 sessions. We tested each one, and session 1 is actually the most accurate one that we have, and that's what we'll be using for this demo. You also need credentials to be able to access this. Once you set up, you'll have credentials, and you'll need to put those as well. Ignore the tag list size right now. And then for this specific demo, you can also add filters. So you can put the beginning of the EPC and you put the company's status, what you're expecting to read, and then you can leave the last section so you can know exactly. You're only filtering the tags that you want. You're whatever is not part of the palette, it'll filter it out, and you won't have it in your reading and in your methodology test. And you can also do in a specific EPC, so you can put the specific tag, and they can tell you what tag you're actually wanting to read, and they'll show you where it's at. For this, you need to insert the file. The file for it will be all the tags in each box that it's in. So for this, we had to take it apart and verify that each EPC, what's in each box, and we also numbered each box. So everything is numbered from 1 to 200, and then the tag 1 through 6 in each box, because it's 6 boxes in each 6 golf ball package in each box. So that's how we were able to capture the data. Let me insert that. So here we have a status that will tell you anything that is completed. So here you can see that it was already in there. So we can go up to the next tab. The next tab will be the tag details. In the tag details, you'll be able to capture, you'll be able to see all the EPCs and all the antennas that it's reading on. Before you can do this, you need to insert a test name. If you try to read without a test name, it won't let you. You need to insert a proper name for you to be able to use it. So for this example, I'll put test 1. We'll run it. So it'll start reading, processing from 5 all the way down to 1. So it'll first start at 5, and once it stops and it captures all the tags that it can read, it will filter to the next one. It takes about 5 seconds, and each of these antennas takes about it's in milliseconds. That's how it's set up, but it takes about 5 seconds to cycle to the whole thing.
Minimize the teams inside.
Okay. There we go. So it'll tell you once it's cycled, it'll tell you again once the runs are done. Okay. There you go. Kayla will then rotate it 45 degrees, and here in the angle, you update it, you'll put 45. On the top left, as you can see, it'll tell you all the tags that it read. So we have about 4 to 5 tags that we read currently. And we have an antenna sequence. So we have it from 5 to 4, 5 to 1, like I mentioned, starting from the top, going to the bottom. After that, we'll continue to test. We continue to do readings. So there's 2 things that you can do here. You can leave all the data up here, or you can clear just that one reading that you have up here. So I'll show you in a minute. Once it stops, I can clear just that one reading, but the data will still be storage. So there's no need for you to have all this up here unless you want to, or you're doing specific testing for that. We'll wait for it to finish. And then I'll add another angle. So after 45, we'll do 90. He'll rotate that as well. And then I can just clear this out. It'll just clear everything that it has up there. But like I mentioned, the data is still there. We'll continue to do the reading. It'll just create a new layer, and it'll cycle it the same way. And it'll still keep adding the tags up here of the total tags that it's actually reading. Up here, it's also keeping a number, but it's including the tags that it's rereading. So if for antenna number 5, you see the tag 18, it's seeing it 11 times. It'll keep that up here, storage with everything else that it's reading multiple times. All right. We're gonna continue to do each side at 45 until we finish, and then we can show you how in the heat map we can demonstrate what it read well and what it didn't read as well. We'll show you that once we can capture all of these. So it takes about 5 seconds. This could be either something that you can have someone doing, or if you have some type of pallet that you can have it manufactured so it can rotate 45 or whatever angle you want it to rotate. And that's something you can guys add as well, depending on how you want to do it. Okay. And then for me, I don't mind too much the data being up here, but with all of this, you can also filter it so it can be numbered correctly. So over here, I filter it, and they'll bring up all the tags that it's capturing that are not part of it, but then it'll also number it from the least number all the way up to the largest number. Let me do that right here. It's 1, and it keeps numbering. It keeps going in the proper sequence that it should be in. So as you can see, it has around it has 1,200 tags, and it's already captured more than 1,000 tags. So it's doing a pretty good job at reading at it. So we were able to do this, like you mentioned, because we added the linear antenna at first, because the ones on the sides, they're accurate, but they don't go the distance is not as great. and they won't read out on the outside of it as well. So the linear will be able to not just read centerfied, but around it, and that will be able to capture a better read for us. And we tested that multiple times, and we did figure that was the best thing to add. And I think we're coming up to the last one. We won't go all the way to 360 because we already got the first read and it was at 0. So we don't want to retake that initial measurement that we did. Okay, we'll do the last one. Now I'll clear this because I don't want this to be there no more. Just clear it out. I'll get the last reading. So as you can see, it did a pretty decent job, capture most of them. So far, we weren't able to capture all 1,200 tags. This just because it's so many, and we still got to figure out how we can condense that so we can get the whole palette reading. All right. So that's done for the tag details. We'll move into the heat map. So for the heat map, it's actually pretty cool. You can modify it to whatever palette you have size, and we did that with the front side and the front and the side. So the front and the back usually are the same, and the left and the right are the same. So we wanted to keep it that way, and you can just change it for adding whatever you want. You can switch it, and it'll automatically update when you put update grid. We also added a gray outside boxes because sometimes you might use in each space, you might use all of the boxes, all of the corners for you to capture that palette, but sometimes they're incorporated into one of the faces. So you can also do that by clicking up here, you upgrade it, and it'll automatically will let you use all of the boxes within the palette. Let me go back to our original one. I want those grayed out, and we'll back at it. So then also we have colors. Let me process the data and I'll tell you a little bit about the colors. We already have the pre-assessor of all the tags that it should have in there. So once I process it, it'll update. The green is everything that it captured in all the boxes that have all the 6, that is reading all the 6 tags in it. So each of them have 6, so it's reading correctly. This lighter color is saying that it read over 75% of them. So like I mentioned in the color palette right here, it's divided into 3 thirds. The lower third is the least amount of tags that it read. It's under 25%. So we said that to be green, but you can set it up whatever color you want. You can click set color, pick whatever color you choose. You just click OK, and it'll update it for yourself. The middle third that we have here, that we only got one box, it's reading 50% of the boxes of 50% of the tags within the box. So we only have one that is reading about 50% of those. And I can change the color if I want. I don't like that red. I want it to be pink. Click OK, and you set the color on you process the data, and they'll automatically do the color for you. This is just a visual so you can know where exactly the box is if you want to pull it out in case, okay, it's not reading it, but what if the product is actually in there? It's just the taste didn't capture it. I can pull the individual box out and verify that by hand, or you can rerun it if you would like to do that. Also, we added some pictures in here. If you right click and you don't know, hey, I don't know what the front side or the side of my palette is, we have images here that would show you what the front side and the back side would look like. And then also what the left and the right would look like. We also added the layers because sometimes people might want to see that visual image, and it also tells you what the layers is consisted of. We'll move to boxes. So for boxes, we have on the left, everything that should be in there. So each box with what tag in the specific should be in that box. So for example, I'll go to 24 because that's what was wrong in the other one. I click on 24, it'll tell me in the specific what each tag should be in there. If I go over here and click on 24, I can compare it and say, hey, so I was able to see 19, 20, but I didn't capture 21. There's the tag is missing in there, and I can verify that and I can see which one it is. On the right side, we also added a cost analysis. So you can insert whatever the amount of whatever the cost is for each individual box. So let's say it's about we said it was about 50, but you say it's about 25 each. You insert that and automatically it'll tell you the pallet value based on the heat map with the last box that it has in there. So it automatically will update that and give you the calculation. And we wanted it to be something that is incorporated in here because when we're talking about product, sometimes you might say, okay, it's missing 5 tags, but what if those tags are each $1,000? Then it's you see it in a different way. So we wanted to incorporate that and also put the missing value and the missing tags because as you add the visual, the user will be more, I don't want to say afraid, but more alert of what is missing, and I want to fix it, see if it's actually in there. Next, we'll move into our box EPC data. For here, it's the same thing. I can click in here and it'll show me everything that should be in there. But the good thing about this, it tells me the tags that it should see in there, how many it found, what layer it's in, and also what side it's on. So for number 1, it's in the front, it's in layer number 1. And then in here, I also added the tags in the box. So it'll give you an image expression of how each individual tag is located within the box. So 1 will start at the top left and 6 will end at the bottom right. So for example, we can go to one of the ones that is missing tags. Okay, to know which one accurately it is, you can go back to the other one and say, okay, it ends at 78. Then you can come over here, 79. It's missing 80 and 81. I can go here and I know 71 will be 1, 79 will be 1. So I know that I'm missing 80 and 81, which will be 2 and 3. And then you'll know exactly where in the box you'll be missing that tag. Lastly, we have boxes 2. That's also another filter where you'll have the completion of all the boxes that are complete within the pallet, and then also the ones that are partial completed, which is they're missing tags. So over here, it'll tell you all the missing EPCs that it has within the pallet. So I'm missing all of these. And over here, it's just all the extra tags that I have. So the extra tags, like I mentioned, we're in the auto ID lab. We don't know how many RFID tags we have in here. So we want to make sure that we're not using that data in our pallet. So we luckily had a filter where it filter it out, and then also will show you what tags you're reading that you don't want to read. And if you somehow want to clear out the room and have that to 0, you can do that depending on how you want to do it. Or if it's a place that has multiple RFID tags and it's a big industry and it's processing them a lot, you can just filter it and it'll read them, but it won't use them in your data. Yeah, that's about it for us. Thank you. At the beginning, we did, and we kind of leveraged to moving the distance between the antennas and the pallet. So we increased that a little more. But I feel like if we increase it too much, it'll then reduce the amount that it can read. So it'll be too close and it won't capture that much. So it's something that we do have to retest and see what it's doing, because it's mainly, as you can see over here, we have some corner ones and then some in the middle. So if it's reading over here, well, why is it not reading correctly with this section right here? So I guess it could involve the angle. But like I mentioned, if we go to 30 degrees, it's still like pretty close, and we don't want to consume that time. So I guess that's a testing that we could do to verify that it could actually capture all of those.
So,
Any more questions?
yeah, so have you thought about, like, I understand the context of the project was to really set up a solution, if you will, on how you can read for palette verification. This is a real world use case. I was just at a client last week where palette build verification is something they want to do. So my question to you is, as you look at this, have you had some thoughts on maybe how you can, like, maybe even combine automation like robotics to try to really kind of, make this a lot more automated and commercialized?
Yeah, so that is something that we thought about, but in this circumstance, we kind of are in the testing phases. So as we were going through it, I'm thinking, hey, this is something that we don't have to do, or you're gonna have a person doing it. You could have it set up where it automatically would turn at whatever degree you want it to be, and then you can have a standard set of that could even be implemented in a wall, and all you have to do is set up the sequence that you want it to be located at in the distance from the pallet to the antennas, and then you can do that multiple times instead of you actually doing it and having something automated. All you have to do is either you could have it just, you pick up the pallet and you take it somewhere else, and that's about it.
That's good. And then one last question: what was like the funnest part of the project? And then
Well, on the most challenging part was at first. So at first, for the setup, I had to go through each box, and we had to go through and put every single tag into an Excel file. So we put 1,200 tags into an Excel file. So you can imagine the pain behind that. And behind it also, we found that most of the boxes were like out of order number wise. So we had to go through and reorganize each box. And some of them didn't even have tags on them. So we had to go through and rewrite the tags. So yeah, you can imagine the time behind that.
Like he said, we're lucky to have Dr. Baruso, but sometimes things don't go his way. So yeah, that's why he got us over here verifying that each box is correctly sequenced to the RFID tag in the pallet. And for me, the most fun was actually trying to fix why we weren't able to capture that many tags. I think it's frustrating, but at the same time, once you're getting it and you're getting the results you want, it gives you that I guess hope that, okay, this is going where I want it to go, and it gives me that joy of like this project is working how I want it to work finally.
Yeah, one quick question related to tags that you missed, and the patterns that you saw in that. So I saw where very very methodical on how you had the tags, individual tags ordered inside the boxes themselves. What kind of attention was paid or not paid? Just curious for the orientation of the individual tags inside the boxes, those 6 tags in the boxes, how close are they oriented to each other? I mean, as far as, were they all lined up the same way? I mean, how much variation do you think that you have inside, say, a box with 6 tags?
Yeah.
If you try to take a linear alignment of them, are they all the same? Did y'all pay attention with the lining very closely, or was there variation? Just curious how you did.
So for that, the tags were already incorporated in there. Okay. So they were Dr. Baruso already had some of those programmed in there. So I guess they were centered within the box, but they were on the front side, so it was facing up. Okay. As you can see, I'm handing a manual. I can also upload that for the people that are in the camera. We have set up where it should be facing full up. So that's the orientation that we have all of them facing. We didn't want it to be just spread out. We wanted everything to be sequel and a standard way of doing it. All right. Thank you.
All right, and we had a question. I'm going to try to do this without feedback. Are you using RSSI value triangulation to provide the zones locations in the carton? And let me get this out of the way. I'll go ahead and address that for them. As kind of outside the scope of what they were expected to get into. We didn't really get into RSSI heavily in class. Short answer is no. The longer answer is I went back and forth about whether to try to use RSSI as part of the analysis about evaluation of the data, and just we're in Memphis. It's humid if we're lucky, it's wet if we're not, and so I kind of made a conscious decision. We'd concentrate more on read rates than on RSSI because of the amount of variability that could potentially introduce. No, there's no triangulation simply because the antennas we're using, this is running off a generously donated FX 9600 from Zebra. And those units, to the best of my knowledge, with the antennas we have, don't give me any kind of angle of arrival information. So not really capable. We could kind of fake it, I guess, but I'm not sure it makes sense to for this type of an analysis. Then the other thing that they didn't mention, and part of the challenge on this, was the product inside the pallet is foil boxes of product. And so they were given the tags. They didn't have to try to select a metal mount tag or anything like that, but there are 1,200 metal mount tags actually on that pallet, and that's why they're having so much trouble getting to that 1,200. So good job, guys.
Thank you.
Thank you. All right, so we're gonna switch gears, and the rest of the projects are going to be around the Atma.io software that Avery Dennison donated earlier this semester. So I do want to again thank them for that and their support of the lab and our students. It's hugely beneficial for the students. It's great for the lab. I think it's good for Avery that they're getting that slightly different perspective on how to use their solutions, which is always helpful. So I see this partnership as a win for everybody, but I will let the first group get to it.